Hi, welcome you again. So, in this lecture, I'm going to teach you about characteristic notation manipulations. That means how we can substitute or multiply or factoring or contract in Tensor. So, I'm going to make you understand about that. So, it's all about. So, the lecture is um, notation manipulation, right? So, no T A T I one notation manipulation manipulation. So in this notation manipulation lecture, so the lecture would be one, how to substitution, one substitution, the number multiplication, one multiplication, and third factoring, and the fourth one would be the how we can contraction. Yeah, so let's get started with the substitution. So how we can substitute in tensor or something like that. Yeah. So substitution substitution. So how we can do that? Mm, So for example, here we have here two equation or two tensors. Say for example here AI equal to U I M, right? Here is the one equation, and the equation is BI equal to VIM and CM, right? So we are asked to substitute two equations with this to here. So but we want to replace this equation to this equation, but if you want to substitute or replace bi, that means here in index is here bi and here index is bm, so factor of indices, so you have to transform the both indices into the one or same indices. For example, the I should be M or M should be I, right? So how we can transform our indices I here with M. So for example here we can write down write down this way. So we can write down say Vm, so Bm, so I, so we replace with B, I with M and M with N, right? So we can substitute here B, Bm, so I with I, so Bm and N and Cn. So we replace I replaced by M and M replaced by N. So we have got this Bm equal to Bmn and Cn. Then we can substitute to here too. So we can now easily substitute to here, right? So we can write down here AI equal to UIM BMN and CN. But we just change we just change from I to M and M to N only to the equation, not only to. That's why I is saying here. Rinko. I is same is as here. So substitution and substitution does occur like that. So this is all about substitution. So multiplication. So what is multiplication? So go to the multiplication, C-A-T-I-O-N. So how can do multiplication? Multiplication is also easier. So for example, here we have one tensor P equal to equal to AM AMBM, and another we have Q equal to CM and BM. So if you multiply this, then P times Q, then our multiplication would be easy. AM BM times CN dm. So not so we know from the matrix, so we know how we can multiply these two matrices, right? So one column should be equal to the one row of and the matrix. So m and n, right, should be the same. So here in this different case, so m, so this should be the mn. Yeah, so we note that so it's important to note that not pq equal to uh, pq is not equal to am, bm, cm, and dm, right? In fact, the right hand side of this expression, that means am, bm, cm, dm is not even defined, right, in the summation convention, and further it is obvious that so so for that it is obvious that so PQ not equal to summation 1 to 3 because 1 equal to 2 3 AM BM, so this whole term so is not equal to okay. So I'm going to make you understand with an example. Say, so we know the dot product of vectors is a distributive. That means if we write down, say we have a vector here A equal to AI EI, right? Here is another vector. Another vector is B equal to BI EI, right? So we can, if we dot product of A and B is equal to A dot B equal to AI EI bracket dot BI EI, right? So dot. So you can write down here. So we can write down something. So good term. So we can here. So we can say here J. It will be better for us because if it's two different terms or something like that, then we can write down here A I B J A. You know, right? Yeah. A I B J. We can write down is the vector is E I dot E J, right? So we know that from the Kronecker delta that EI dot EJ equal to the Kronecker delta. So we can write down AI BJ Kronecker delta IJ. But Kronecker delta from the Kronecker delta, so IJ it is when identical notation have when Kronecker delta have identical notations, then it has value 1, otherwise 0. So we can write down here, right? Here uh, AI BI, right? So all the identical notation we can, if we ignore all the zero, because all the identical notation should be here. So II equal to, so 1 1 B1 plus A2 B2 plus A3 B3. So which is the familiar expression for the evaluation of dot product in terms of the vector components, right? So um, so we saw how we can do that in multiplication. Now we'll see how we can do that in factoring. So factoring is also easy. So factoring FSC factio. So what is factoring? So you know what is factoring. So if we write down here, if we have an application T I J T I J, sorry, if we write T I J N J minus lambda and I equal to 0, then how we can factor it out? And if we write down ni equal to Kronecker delta, say Kronecker delta ij, if it's 1, say 1, right? And j ij, so we can substitute this, so we can pij nj minus nj Kronecker delta is equal to 0. So if we bring out nj, then we get tij minus Kronecker delta ij, right? So sorry, we have a lambda here. So we have lambda here. We have lambda here. Is equal to 0. So we can do that in factoring or something like that. This is the normal procedure or process. So this is the factoring. So another way we have another manipulation notation is the contracting. So here contraction or contracting, something like that. So contraction. So contraction is nothing but to reduce the number of indices here. So for example, here if we have indices I, J, K, then contraction, what the contraction would do, contraction would reduce the number of indices. Say maybe it may do that I, K, or I, J, right? So it doesn't matter because it reduces, we have three indices here, right? But it reduces the two, I, 1 and K. So I, J, so it reduces. So we can give an example of that. So it's important to say, we have equation say Tij, so we would contract to either Tii or Tjj. So what is, so write down Tij equal to lambda del, and we have Kronecker delta ij plus 2 mu Eij, right? So we have two notations here, I and j, so we have to reduce either Tii or Tjj. So how we can do that? Let's see. Yeah. So T, you can say, for example, we can write down here Tii instead of J. We can write down here. So lambda lambda del, so we can write down the Kronecker delta I because all the we substitute with I, and we can write down here 2 mu E I and I, right? So we know that T Kronecker delta is 3, so I is equal to 3, right? So 3 lambda delta plus 2 mu E and I. So we reduced. So see here we have two identical notations, and the index is the same, right? But here index is a 2, here index is 1. So these are the contract. These things are contraction, nothing else. Okay, so I hope you have enjoyed this lecture. I'm going to see you on the next lecture. Thank you.